In the next two examples, we want to look at how we can use logarithms to solve exponential equations by first taking a look at the expression log base b of x. That's going to be equal to x times the log base b of b, because we can use the power rule of logarithms to bring that exponent down as a factor in front. And anytime we have the log base b of b, anytime the log and the expression we're taking the log of match, we get 1. So this expression is going to be equal to x, meaning we can use logarithms to cancel out exponential equations and get something simpler to work with. In example 4, we'll take the log base 10 of both sides, or just the log, but we know that it's implied that's base 10. On the left-hand side, the log base 10 of 10 to the negative 3x plus 1 will just leave us with negative 3x plus 1. And then on the right-hand side, we'll have the log base 10 of 1. The log base b of 1 is always equal to 0, so we'll get negative 3x plus 1 is equal to 0. And keep in mind, if you forget that property, you can always rewrite this as 10 to some power has to equal 1. The only value there that would work would be 0. And then we'll solve from there. By subtracting 1 from both sides, we'll get negative 3x is equal to negative 1. So x is equal to 1/3. We'll use the same trick in example 5, but first we need to isolate that exponential expression by itself. Adding 6 to both sides will give us e to the 5x minus 5 is equal to 12. Now what we need to do is take the log base e of both sides, which is the same thing as the natural log. Natural log and e will cancel each other out to leave us with just 5x minus 5 is equal to the natural log of 12. From there, we could add 5 to both sides to get 5x is equal to the natural log of 12 plus 5. And then in our last step, we'll divide both sides by 5 to get x is equal to the natural log of 12 plus 5 divided by 5. From there, we could use a calculator or other technology to come up with what the decimal approximation of that would be. But if what we want is to keep our answer in exact form, this is the expression that we would enter as that solution.